Okay, this is a very quick overview of the chapter of heat transfer. This chapter is not very difficult concept-wise. Most of you already probably can understand this chapter relatively well, and it's not that difficult, right, in terms of understanding. Okay, but the problem is not so much in understanding, but probably maybe in answering questions. Okay, sometimes you may think you get all the marks, but you don't always get everything correct. Okay, so let's just run through this quite quickly. Okay, first of all, there's conduction, is conduction, convection, and radiation. So for conduction, the key things to remember here, you need to remember, probably need to memorize very well the molecular description in solids and in metals for conduction. So for example, in solids, you have to use the keywords like when one end of the rod is heated up, okay, the particles start to vibrate about a fixed position and they will collide with the neighboring particles and passing on the energy from one to another, right? So keywords must be there. And for metals, why metals are good conductors of heat? They have what is known as free electrons. So when the free electrons gain energy, they will start to move freely among the atoms and they will collide with them and they will pass energy along as well. Okay, the other thing about conduction, which I think all of you know, and it is a key phrase, very good to use in answers, is that air is a poor conductor of heat. Right, then we move on to convection. Okay, convection, the keywords, key phrases that you need to have when especially describing the process of convection. Okay, less dense, more dense convection current. So when a hot air is heated up, right, the volume increases, and as the mass remains the same, it becomes less dense. So this hot air will rise, and then the cooler air will sink because it is more dense, and this sets up a convection current. So remember to have these three keywords in your answer. Okay, then we talk about radiation or infrared radiation. Okay, remember, what do you need to remember? The key phrases here. One, that radiation can travel through a vacuum and does not require a medium. Okay, whereas your conduction and convection processes both require a medium. And other things which are obvious to you, okay, which I just want to reiterate how important these phrases are. That black is a good emitter of radiant heat, black is a good absorber of radiant heat, whereas shiny surfaces are poor emitters of radiant heat, right? Or you can also say that they are good reflectors of radiant heat. So all these phrases here are very good to have in your answers, right? And you have to be, when you're answering, to be specific and clear in using it, right? Okay, now, then again, there are some wrong phrases, wrong terms, wrong words which we often use in our answers. For example, we like to say that black is a good conductor of heat, right? That is not correct. You are implying that color has to do with conduction. That's not true. You can say, right, the material, yes, the material copper, okay, copper is a good conductor of heat. Yes, you can say that. But you can't say that black is a good conductor of heat. Neither can you say that silver is a poor conductor. You should actually say that silver is a poor absorber of radiant heat, right? So careful over here. And then when asked about convection, somehow this always creeps up in wrong answers, that students say the liquid molecules expand when heated. Okay, that's not true. Don't ever say that. Neither should you say that the density of the molecules decreases, that's why the hot water rises. No, is that the molecules get further apart. Okay, the density decreases, the density of liquid decreases, that's why the liquid rises. Okay, and don't say things like this. Also, heat is trapped. It's not that heat is trapped, but is that the hot air is trapped. Okay, and this prevents convection current from being set up. Okay, convection current cannot be set up. And also things like hot air is lighter, okay, cold air is heavier. Okay, don't use such terms like this. Okay, so this, in just a few minutes, these are the key points of this chapter, right? Okay, so the next thing I want to talk about is your approach to answering heat transfer questions. Okay, what should your approach be? Okay, your approach should be, firstly, look at the situation at hand. Read the question carefully, right? Is this a case where is absorbing heat or giving out heat or keeping the heat in? Okay, what is the situation about, right? Read it carefully, because if you misinterpret it, you may answer it in the opposite way, and then everything goes wrong from there. Then after that, when you have read the situation, look at the diagram. Usually the diagram gives you lots of clues as well. Identify the processes involved. Okay, there may be more than one process. So it may be conduction, it may be convection or radiation, maybe all three. So look at which of them is involved. Once you have identified process, think about the key phrases, KP, or keywords associated with the process. So if the question is all focused on conduction, think about the phrases that you want to use in conduction. If it's about convection, think about the phrases, the keywords you want to use in your answer for convection, like what? Less dense, more dense, and convection current. Okay, and then fourthly, the one which probably most lacking is relate back to the situation. So you already have written your answer, everything, then your last line should relate the situation, relate back your answer to the situation involved. Okay, how does this keywords, key phrases pertain to this situation? All right, so that's a very quick overview.